Good morning, everybody. It's an honor for me to be with you today and sharing a part of my work with you entitled Synergy Effect over Electrodeposited Copper Oxide thin films in Photocatalytic Degradation of Methyl Orange. In order to simplify our presentation, we proposed for you a schedule of this presentation. Firstly, we will start by an introduction. Secondly, we will pass a description of the experimental section. Thirdly, we will discuss our results. Finally, we will finish by a conclusion. The textile industry has a strong impact on the pollution of the environment by its rejects, which are strongly contaminated by azodase. The azodase is composed by two benzenic cycles regrouped by an azo group for forming the azobenzene, and the methyl orange is a model of these bases. The methyl orange characterized by a light resistance, resistance to acids, resistance to oxygen, and resistance to the base. So our problematic is how to treat waste from the textile industry. For this reason, several processes have been taken into consideration, such as adsorption, electrodialysis, reverse osmosis, ultrafiltration, and photodegradation. The photodegradation is based on the elimination of a semiconductor, generating the formation of electron-hole pair, causing the formation of oxidation and reduction reactions, which leads to the generation or oxidation of the organic pollutants. After this, we will pass to the criteria, the catalyst selection criteria. The catalyst would be stable, non-toxic, low cost, a high reactivity with oxidizing agent, absorbance in the visible range, and the copper oxides was chosen as the best candidate for this study. After this, we will pass to the experimental section. Electrodeposition of copper oxide. Copper is a multivalent metal, very abundant in nature. It reacts with oxygen to form the copper oxide, paramelaconate, and tellurate. The electrodeposition of copper oxide was carried out in the three classical electrode on aqueous substrate from acetate bath at pH of 5.8 at room temperature. The film obtained was characterized by microscope electronic scanning, and the obtained results show the formation of downgrade of copper oxide for the both potentials, for potentials of minus 0.16 volt and minus 0.17 volt, and the potential of minus 0.17 volt. The film deposited covers the all surface of the substrate, and the structural characterizations show several peaks of copper oxide with different structures. The optical characterizations of the film deposited show the high absorbance in the visible range, and the huge absorbance is for the potential of minus 0.70 volt, and the optical gap for the both potentials was 2.25 electrovolt for the potential of minus 0.16 and 2 electrovolt for the potential of minus 0.17 volt. The good performance of copper oxide's film allow it to be a good candidate for the photocatalysis. For this purpose, the copper oxide have been tested on the degradation of the methyl orange. The experimental process of the photodegradation contains the solution of the methyl orange and the film of the copper oxide with presence of the H2O2 at temperature of 70 degrees C, and the wood is exposed to the UV radiation. The result obtained show in figure 5 the absorbance spectrum of the methyl orange with and without the presence of H2O2. We can see in this figure that the band in the 465 and 485 nanometer range in the visible region that is attributed to the isotherm. Other bands at the 276 nanometer and 37 nanometer are due to the presence of the benzene cycles in the methyl orange, as well as a change in the p-electron delocalization system in the orange methyl structure. The addition of H2O2 to the solution results in the decrease in pH from 5.8 to 3.14. Upon protonation, the color of the solution changes from the orange yellow to the red due to the formation of a monoprotonated form of the methyl orange. The latter exists are resonance hybrid between its skinin and diimine and azonium structures. A more intense absorption band shifts to a longer wavelength, the 5.6 and 5.18 nanometers. The band in the visible region can be attributed to azonium ions. A new band at 226 nanometer in the UV region appears due to the change in the p-electron delocalization system. The figure 6 shows the absorbance spectrum of methyl orange during its degradation as a function of eliminated time. It can be seen that the absorbance peak decreases as the elimination time increases. In other words, the concentration of the pollutant in the solution decreases. After 75 minutes of exposure to UV light, the absorbance peak of the methyl orange disperses. This implies the total degradation of the methyl orange. The figure 6c shows the evolution of the rate of degradation in presence of H2O2 as a function of elimination time. Taking in consideration the results obtained and in the light of the spectra of figure 6b, the suggested degradation mechanism of methyl orange is described in Chem 4. Finally, we can conclude that the copper oxides obtained show a dendritic morphology with a high absorbance in the visible range with optical gap between 2 and 2.25 electrovolt with a high degradation rate. And thank you for your attention.